Assalamualaikum. Hi everyone, I'm Cikgu Niswan. Water is the most common solvent. When solid dissolves in water, we refer to the solution as an aqueous solution. I believe that you have ever tried this experiment before, preparing saturated aqueous solution of copper to sulfate. Start with adding small amount of solid copper to sulfate and continuously adding more copper sulfate until stage is reached where the solid appears as a solid precipitate at the bottom of the solution. The solution form is called saturated solution. At this level, you should be able to explain this observation using the concept of solubility equilibrium. Students, these are learning outcomes for this video. Let's imagine an experiment in which I have 100 milliliters of water at 25 degrees Celsius and I add solid silver chloride a little at a time, which is exactly weight. Stirring between each addition and analyzing the solution to determine the concentration of silver ion and chloride ion. The results of the experiment might look like this. When I add 1.86 times 10 to the negative 4 grams of silver chloride to the solution, the concentration of silver ion is 1.3 times 10 to the negative 5. Since 1 mole silver chloride dissociates in water to give 1 mole of silver ion and 1 mole of chloride ion, at this point, concentration of chloride ion is also 1.3 times 10 to the negative 5. Keep adding solid silver chloride, but the concentration of silver ion and chloride ion remain the same. Equilibrium has been established, meaning that the solid continues to dissociate and ions continue to recombine to form the solid. The rate of dissociation is equal to the rate of precipitation. At this concentration of silver ions and chloride ions, the solution is saturated. Adding more silver chloride results in the precipitation of solid silver chloride. We can conclude that saturated solution contains the maximum concentration of ions that can exist in equilibrium with the solid salt at a given temperature. C. Adding more solid silver chloride will not increase the concentration of ions in the solution. Again, refer to this equilibrium reaction equation. We can write a mass action expression for the system as this. However, you have learned that a concentration of a solid is a constant. Hence, Q is equal to the concentration of silver ion times to the concentration of chloride ion. Note that Q is the product of the concentration of dissolved ions in the solution. The expression is known as the ion product for silver chloride. From this column, you can see that the value of the ion product is increasing, but is less than the value of 1.7 times 10 to the negative 10. Equilibrium has not yet been established. You can see at equilibrium, the ion product equal to concentration of silver ion times to the concentration of chloride ion is constant, equal to 1.7 times 10 to the negative 10. At equilibrium, the ion product is called solubility product, symbolized as Ksp. Note that Ksp is an equilibrium constant, so it is temperature dependent. This is general equation when dissolving slightly soluble salt and its general solubility product Ksp expression. Let's say you have to calculate the molar solubility of silver chloride at 25 degrees Celsius. Means you have to calculate how much silver chloride in moles will dissolve in 1 liter of water at 25 degrees Celsius. Given Ksp of silver chloride is 1.7 times 10 to the negative 10. To solve this problem, you must identify the relationship between what you know and what you need to find out. Dissolving silver chloride in water should be considered as an equilibrium reaction, right? So we need to set up a concentration table. See, neither silver ion nor chloride ion is present in solution at the start. There is no entries in the column under silver chloride solid because this substance doesn't appear in the KSP expression. In the change row, we enter data on how the concentration of silver and chloride ions change when silver chloride dissolves. Because dissolving the salt always increases the concentration of the ions, this entry is always positive. But we don't know the change, so we will define our unknown X as the molar solubility of the salt. That is the number of moles of silver chloride that dissolve in 1 liter solution. So, mathematically, our X value equals to 1.3 times 10 to the negative 5. At this point, you should be able to answer this question correctly. Students, how do you predict whether a given concentration of ions will result in the precipitation of ionic compound? Actually, you can use the relationship between the ion product expression and the solubility product expression to predict whether a precipitate will form in a given system. The ion product, QSP, is an expression that is identical to the solubility product constant, KSP, but its value is calculated using concentration that are not necessarily those at equilibrium. This is the relationship between QSP and KSP in predicting the formation of the precipitate. We will discuss in details about this. There is one common system to predict the formation of a precipitate, that is, involve mixing solution of two soluble ionic compounds which react to form an ionic compound with a very low solubility. Previously, you have learned a set of solubility guidelines like this, right? Actually, no salts are completely insoluble in water. It is just that the solubility of such salts is very low at room conditions and thus considered insoluble. Let's say we have this situation. Involve mixing of magnesium nitrate and sodium carbonate solutions. We can write the overall reaction equation and the net ionic equation like this. When these two solutions mix, clearly we will get solid of magnesium carbonate salt. Since magnesium carbonate is slightly soluble salt, applying equilibrium concept, solid magnesium carbonate is said to be in dynamic equilibrium with its aqueous ions, and the QSP equal to concentration of magnesium ion times the concentration of carbonate ion, meaning that we need to know the concentration of these two ions. Students, please bear in mind that volumes add up when we mix solutions. We must use the add up or total volume when determining the concentration of solute in the solution. So mathematically, we will get the concentration of magnesium ions and carbonate ions respectively. Now, substitute the ions concentration into the ion product expression for magnesium carbonate to determine the value of QSP, which is equal to 7.5 times 10 to the negative 6. Now, compare QSP with KSP. Since QSP is less than KSP, solution is not saturated, meaning that most solute still can dissolve in it. No precipitate would form. You should try more questions on this concept. Look at this situation. We already have saturated silver chloride solution, meaning that we have maximum concentrations of silver ions and chloride ions, which is equal to 1.3 times 10 to the negative 5 respectively. Now, we add a little sodium chloride solution to the saturated silver chloride solution. Finally, we observe that there is a white precipitate formed at the bottom of the solution. What is happening? By adding sodium chloride, makes the total of chloride ion concentration increase. According to Lee-Chetry principle, the position of equilibrium will shift in order to counter what we have done. In this case, it will tend to remove the chloride ion by making extra solid silver chloride. That is, the equilibrium shift to the left. That is, some silver ion will combine with added chloride ion. The silver chloride will become less soluble. So the concentration of silver ions in the solution will decrease. A common ion is an ion that is found in both salts in a solution. The lowering of the solubility of an ionic compound as a result of the addition of a common ion is called the common ion effect. Okay, here is a simple calculation to show how the common ion effect works. Initially, when silver chloride dissolves in water, the concentration of silver ion is 1.3 times 10 to the negative 5 molar. When we add in sodium chloride solution, the sum gets different. Let the solubility of silver chloride be Z. This time, the concentration of the chloride ion is governed by the concentration of the sodium chloride solution. The number of chloride ions coming from the silver chloride is going to be tiny or small compared with the 0.5 molar coming from the sodium chloride solution. In calculation like this, you can always assume that the concentration of the common ion is entirely due to the other solution. So, we assume concentration of chloride ion in the solution equal to Z plus 0.5 molar and equivalent to 0.5 molar since Z is very small. Thus, mathematically, we can show that value of Z, which is the concentration of silver ion in sodium chloride solution, is 1.13 times 10 to the negative 9. Clearly, the silver chloride ion solution has decreased with addition of common ion into its saturated solution. Okay, students, try to answer this question. That's all for today, students. See you in the next section. Bye!